Go and open your book to page 213. Today's lesson is on the distance, rate, time problem, or more commonly called is the motion problem. So motion problem is when object is moving, like an airplane or train or car, or when you're riding a bicycle or you're walking. So you move. So when object or something is moving from place to place. Okay. Now the basic equation that you need to know is r times time equal to distance. So r is the rate or like the speed. T is time, and d is the distance. So how fast you're going and how long it takes will give you the distance. So like in the morning when you come to school, right? If you ride in a vehicle, you go in a certain speed and times by amount of time, and you can figure out the distance, how far you travel. Okay. So let's go over example 1 very quick. So example 1, it says, if Mrs. Peterson drives at an average rate of 47 miles per hour, okay, so that's the rate means R, so it's 47 miles per hour. And it says, how long will it take her to drive 320 miles, 29 miles? So how long, so you're talking about T. So T equal to question mark to drive 329 miles, so that's D. So distance equal to 329 miles. Okay, so again, you use the formula. So you always start with the equation, right? So R times time equal to distance, and you substitute whatever you know in here. So 47 times time equal to 329, and you divide by 47, so T equal to, and so you can get your calculator and you work it out, it would be 7 hours. Okay, so this is just kind of give you an example of how to use the formula. Okay, but this is easy kind. But the problem that we're going to be doing would be almost like in a way like a mixture problem kind. So you have to make a table. Okay, so the table for the motion problem would be the table would be, again, you're going to make so again you want to make it into the four. Let's go and make into four rows, okay, and so this one you don't need a total, okay. So again, you always write the equation down on the side, okay. So it'd be R times time equal to distance, okay. Again, I draw the double lines over here so you can see that you multiply to get these, right? Just again similar to the mixture problem we had. Now on the top is always a name, right? Like a name of a person in work problem, or like a name of the object you're mixing, right? Over here would be the name of the person, or like a car or whatever, right? So again, up here would be the first item and would be your second item, okay, of the object. So let's go over more examples and how to use the table. Again, the purpose of the table is to help you to organize all your information so that so it's not as confusing. Okay? Now you can solve the problem without using the table, but it would be more confusing. Okay? Okay, so let's go to example 2. So let's go to page 215. Example 2. One more additional thing you need to do for motion problem is that you need to draw the picture. The picture with all the numbers on the picture, it helps you to figure out what you're supposed to do. Okay, so example 2, it says it takes Mr. Maxwell 1 hour to drive to work in the morning, but it takes him 1.5 hours to return home over the same route during the evening rush hour. If his average morning speed is 10 miles per hour faster than his average evening speed, how far is it from his home to his work? So first, you read it one time to figure out what type of problem this is. So this is a motion problem because it's moving. Okay, Mr. Maxwell is driving from home to work. So you're going from one place to the other. So that is the motion problem. So for motion problem, you need to go and draw a picture. So for the word problem, you need to be patient. You need to read over several times. First, you read to figure out what type of problem it is. So now you know it's motion problem. Then you have to read it the second time to draw a picture. Okay? So it takes Mr. Maxwell 1 hour to drive to work in the morning. Okay? So over here is home, and he's driving to work. And it says 1 hour. So over here, t equal to 1 hour. So you want to get all the numbers on the picture. Then it says, but it takes him 1.5 hours returning home. So when coming back home, now you want to put down here so you don't get confused. So coming back, time is 1, and I'm going to use decimal. Okay, I want to stay away from mixed numbers. So 1.5 hours. Okay, and then it says if his average morning speed, so over here, so speeds are, right? So average speed is 10 miles per hour faster than, means more than, the average speed in the evening. So you don't know. So over here, R is equal to X. So this is 10 more than the speed over here, so it would be 10 plus X. Okay? So you need to have all the numbers on here. So on the test, you need to draw pictures. This will worth 2 points on the test. And you need to draw the picture with all the numbers on it. So now this is what you have. Okay? So now your next step is to draw your table. So notice the table is different from the book, right? So I don't want you to do it the way the book is written, okay? So I want you to do it the other way. So I want you to make R, T, and D on the vertical. And over here, again, that way it be consistent. Notice every type of problem, the name always goes on the top, right? So over here, this would be going to work, right? Go. And this is returning home, return. So this is coming back. So now let's go and start to fill in the blank. So look at the picture over here, right? So R is a speed. Okay, so how fast was he going to work? Or over here it tells you, right? And I'm going to write this in order, so it'd be x plus 10, right? So going, and the time is 1 hour, and the distance you don't know, right? So leave it blank. Now return. Okay, when you're coming back, the R is x, right? The speed is x. The time is 1.5. Okay, so that's all the information you have. Now again, what you need to do is just like the point before, you need to multiply, right? Because remember the equation we did, example 1, R times time equal to distance. So again, you multiply down the column, so multiply, right? Now your next step is you have to figure out what is the relationship between these two, okay? So the distance, D is the distance. So you have to figure out, you have to look at the problem again, read the problem again to see what is the relationship between the two. So this is what makes the motion problem a little bit difficult, because you have to think. You actually have to think now. Okay, you got to read and think. So it's not automatic. So you have to read. So what's the relationship between them? So the distance going and distance coming back on the same route. So if it's on the same route, the distance would be the same, right? So the distance for going will equal to the distance coming back. Okay, so you have to read the problem to figure out what's the relationship. So if they are same, then they're equal. So sometimes you have to add to equal to the total distance. So it depends on the problem. So that's why for the motion problem, you have to read carefully and do exactly what it says. So now you go and solve, right? So minus x on both sides. So you're going to get 10 equal to, now 1.5x minus 1x will give you 0.5x. Right? 1.5 minus 1 gives you 0.5x. So you need to know how to subtract. Then you divide by 0.5, divide by 0.5. So x would be equal to 20. Okay? Now don't box that yet. You have to go back and answer the question, because this is not the final answer. A lot of times it's not the final answer. Okay? It asks you how far is it from his home to his work. So it asks for how far from home to work. So distance. So you're looking for this. So that's what you're looking for. Okay? So the distance would be x plus 10. Okay? So distance you're looking for would be 20 plus 10. So distance you're looking for would be 30 miles. So this one you have to read a lot. You have to keep going back and read to make sure you answer the question. Okay? So again, so let's go over a few more examples. So let's go to example 3. Okay, so you can read through one time. So a boat cruised downstream for 4 hours before heading back. After traveling upstream for 5 hours, it was still 60 miles short of its starting point. If the speed of the river was 4 miles per hour, find the speed of the boat in still water. Okay, so again, you need to draw pictures. So you have a boat going downstream. Okay, so draw a boat and it's going downstream. Okay, for 4 hours. So T equal to 4 hours. Now make sure you read the story and do exactly what it says. Okay? And so it goes downstream for 4 hours and it's going to turn back and going upstream. So now it's going to go back upstream and it's go back upstream and for 5 hours, so T equal to 5 hours. But because when going upstream, right, the water is pushing it back. So even though it goes 5 hours, but it's still 16 miles short. So it's still kind of short by 16 miles. So it didn't quite make it back yet because of the water. Now it says the speed of the river was 4 miles per hour. So the speed of the water is going down this way. Okay, it's going down this way. Right? The water always flows downstream. Okay, it's common sense. But you would be surprised how many people will get confused. Okay, so the water is going downstream at 4 miles per hour. Now, when a boat turns around, does the water turn around with the boat? No, right? So the water is still going to go down this way. Okay, so the water is still going down this way, but the boat is going that way. Okay, so the water is still going down at 4. Okay. 4 miles per hour. So now you're going to make a table. Right, you can always draw the picture. So again, the motion point, you have to be patient. You got to read, keep reading, like many times. Okay, so again, it's R times time equal to distance. Okay, and this is for going down, and this is for going upstream. Okay, so now you have to be careful. Now you have to think now. So when it's going downstream, it doesn't tell you the speed, right? So it would be speed of the boat plus 4. The 4 is the water. So again, it's going downstream, so the boat is going, and the water is going at 4, so water is going to push it to go faster. Okay, so whenever you have whenever you're going with the water, or when you're in an airplane flying with the wind, so you have to plus when it's make you go faster. And then when it's going upstream, it would be speed of the boat minus 4. Because the water is going to push it back. See, over here, the boat is going up, but the water is going down, right? So it's pushing it back. So you have to minus. Over here, the boat is coming down, and the water is pushing it faster. Okay? So you got to take that into consideration. And the time is 4 hours, and the time over here is 5 hours. The distance it does not tell you the overall distance, so you don't know. But you can multiply, right? So this would be 4b plus 16. This one, when you multiply, is 5b minus 20. Okay, so now you have to look at the relationship between the distance. Notice the distance. This is going down, right? Okay, so notice the down. The down distance is equal to up plus the 16, right? Notice it didn't quite make it, right? So the down, so look over here. So distance going down is equal to the distance going up plus the 16 over here, right? So you got to look at your picture. Okay? So you got to look at your picture. So the distance going down is this over here. So it's 4b plus 16. The distance going up over here is 5b minus 20 plus 16. Okay? So now you're going to solve. Well, you got 16 and 16 over here, so you can go and cancel them out, right? You got 16 on both sides. So you can minus 16 on both sides. Then after that, I'm going to minus 5b, minus 5b. So you got negative 1b equal to negative 20. Divide by negative 1, divide by negative 1. So b equal to 20. Now, don't box it yet. You have to go back and answer the question. Make sure that's what it's asking for. Let's see what it's asking for. It says find the speed of the boat in still water. What it means is that find the speed of the boat, not counting the water. Okay? So only the speed of boat only, no water. So in this case, that's it, right? B stands for boat, right? So it'd be miles per hour, and that's it. Okay? So the key to do motion problem is you have to read many times. Read carefully. Process. Don't just read one time and give up. Don't just read twice and give up. Don't just read 3 times, then give up. Okay? Sometimes you have to read like 5 times. So you have to be patient. Okay? Okay, let's go over more examples. So let's go to page 217. Example 4. Again, read the problem. It says, Terry drove from her home to San Diego to pick up her husband, Nick. She encountered heavy traffic all the way and averaged 45 miles per hour. They encountered no traffic on the way home and averaged 63 miles per hour. If the total driving time for the trip was 12 hours, how far is the home from San Diego? Okay, so again, it's a motion problem, so you got to read it one time to get what kind of problem it is. So you know that it's a motion problem. So now we have to draw a picture. So again, driving from home to San Diego. Okay, so let's go and read. Terry drove from her home to San Diego to pick up her husband, Nick. She encountered heavy traffic all the way and averaged 45 miles per hour. So R equal to 45 miles per hour. So this is heavy traffic. Okay, so this is heavy traffic. Now on the way back, no traffic. So again, you got to get all your information together, right? Okay, so they encountered no traffic on the way home and averaged 63 miles per hour. So R equal to 63 miles per hour. Now notice I put information above and I put information down below, right? I don't put anything in here because if you put information over here, you're going to get confused. Is this for the top or for the bottom, right? Sometimes you get confused. So if you do it this way, you know that all this is for the top, all this is for the bottom. So try not to put anything in between here because you're going to get confused between, if it is for the top or the bottom. Okay, then next one is the total time is 12 hours. So don't put a time over here because this is for going, this is for coming back. You have the total, so you got to put it off on the side. So the total time, so put this off on the side for now, equal to 12 hours. Okay? So now what you need to do is go and make the table. So R times time equal to distance. So this is I'm going to use heavy traffic. And this one has no traffic. Okay, so let's walk it through. So it tells you that so for heavy traffic, R is 45. The time you don't know, it doesn't tell you. Don't put 12. 12 is for the total. It's not for going. So you cannot put 12 over here. So don't do it blindly. So you don't know. So you can call it, I guess you can call it H. Okay, for heavy traffic time. And that's it. So no traffic, the speed is 63. The time, it doesn't tell you. So I'm going to put in for no traffic. Okay? And so again, this is the time for going. This is time for coming back. And it tells you the total. So this one actually is equal to 12. Okay, the time, right? The time for going, the time for coming back equal to total. So you can put total time over here. Now, next is, again, you always multiply down, right? So you're going to get 45h, 63n, okay? Now you have to write your equation. Now you got two variables, right? So you need to write two equations. So the time, the relationship between time is that the time going and the time coming back equal to total of 12 hours. Now you have to look at the distance. Again, you have to think, right? The distance going and distance coming back are what? Equal, right? Because you travel on the same route, right? So you got 45h equal to 63n. Okay? And so what I'm going to do is I'm going to use elimination method. So I'm going to move this to this side and flip over. So I'm going to minus 45h. You know what? Let's not do that because h is first. Let's follow this. So I'm going to minus 63n. So minus 63n. So I got 45h minus 63n equal to 0, right? I'm going to use elimination method. Now, since this is already negative, I'm going to multiply by 63. Okay? Now, if you're smart, okay, instead of multiply to make it bigger, I'm going to divide by 9. Notice always a divisible by 9. So I'm going to divide by 9 to lower my numbers to make it a lot easier to do. So again, you're allowed to lower your number. So dividing by 9 first. So I get 5h minus 7n equal to 0. Okay? So now I'm going to multiply by 7. So now a lot easier to do, right? So I get 7h plus 7n equal to 84. And I'm going to put underneath here. Put this under here. So when I add, this cancels out. I get 12h equal to 84. Divide by 12. Divide by 12. So h equal to 7. And come over here. So I get 7 plus n equal to 12 minus 7 minus 7. So n equal to 5 hours. Okay? Now, don't box here. You have to go back and answer the question. It says, how far is the home from San Diego? Oh, okay, we waste time doing this for nothing. He asked for the how far. Okay, so you're looking for this over here, the distance. So you're looking for 45h. So the distance equal to 45 times 7. So distance equal to 315 miles. Okay, and that's it. Okay, so again, you got to read so many times. Okay? Okay, so let's go and do some practice. Okay, for this one.